better to do things in the right time. Fine. If you start revising now also, it's fine. Remember one rule, okay? That 15 minutes, 15-minute rule. And if you follow this religiously, I mean, it will help you in, I mean, words cannot describe how it will be helping you. What is 15-15 rule? 15-15 rule is 15 minutes after the class. Whatever I have taught in any teacher and any teacher, whatever they have taught, just revise that material for 15 minutes. Okay, revise that materials. And when I say revise that material, that means you have to speak, you have some notes. Okay, fine. So Cn negative, in Cn negative we have two nucleophilic sites, and I have a nucleophilic site in carbon, and I have nucleophilic site in nitrogen atom. But in both of them, which one will be attacking? The one which forms a good bond. Which forms a good bond? The carbon forms a good bond. The carbon nitrogen is not such a great bond. Hence the carbon will attack, and hence the carbon is the nucleophilic site here. These type of nucleophiles are also called ambidentate nucleophiles. Just say these words after 15 minutes after the, I mean, you have to spend 15 minutes after the class, and same thing 15 minutes before the class. Okay, 15 minutes before the class. Now this is how much time? This is just, I mean, this is half an hour. And if you do this for every class, you are revising that material for half an hour daily, it will stick in your mind. Okay. And the next thing is that the first one thing is prepping your mind. Right? First, you have to get in that mental condition that you are going to be taught something. And for that, you have to revise the earlier material. That is for 15 minutes, that is before class. The second thing is reinforcement. This happens after class. This is before. This is 15 minutes after. Now, this 15 minutes is not a strict rule. I'm just saying that you have to spend that particular some amount of time before and after class for the material that you are going to be taught and for the material that has been taught. Okay. So if you do this, then you will not be struggling with Marconikov and anti-Marconikov right now. It's fine. So much of lecturing. Alcohol, phenol, and ethers. Alcohol, phenol, and ethers. Now in alcohol, phenol, and ethers, first we will learn about alcohol and phenols and then ethers. Alcohol and phenols and ether. Okay. Now a bit of nomenclature here. I'm just asking the names of these compounds. If you are able to tell me, then it's fine. We will move on. CS3, C2OH, CS3, CH, CS3OH, CH3, CH2, O, CH2, CH3. A benzene ring which is attached to OH. Yes, correct, Fatima. Tell me the other ones. I'm not asking mono, di, or tri or anything. I'm asking the name of these compounds. The nomenclature, the IUPAC nomenclature, IUPAC names of these compounds. So I guess Jubana, you don't. Jubana, can I have you please?
Sir.
You don't know about IUPAC nomenclature, IUPAC names.
So I know.
So then, what will be the name of this compound? What is the name of this compound? CH4.
Methane.
What is CH3? CH3.
Ethane.
Okay, fine. Then what will be the name of this compound? You don't know that, huh? No, yes, anything, please come on fast. You don't know how to. You don't know how to name these compounds, right?
Sir, I know.
So then say it now.
Is it ethanol?
Ah,
Ethanol?
it is ethanol. Ah, it is ethanol. What about this one?
Butanol?
How many carbons are there?
3.
So what will be the main chain? What will be the parent hydrocarbon?
Okay. So methanol.
Are you are just now. I'm
Sir,
asking you answer that, please. What will be the parent chain? If this H was not here, this OH was not here, what would have been here? This would be CH2, right?
yes, sir.
So what would be the name of that? CH3, CH2, and CH3?
Prop.
Propane, right? I have OH, the hydroxy group, OH group. In which position? 1 or 2?
So it's, sorry, sir. 2, second
See,
position. It's in
second.
second.
So what? This is ethanol.
It's propanol.
Not propanol. It is
2 prop.
propane, propane, 2 all.
Okay, sir.
Okay. Now I guess you don't know these, so this will be ethoxy. No, there is no space. I'm sorry, there is no space. Ethoxy ethane. This is ethoxy. This is ethane. Ethoxy ethane. Okay. And the next one is phenol. Now this is what? This is now, Fatima, you have written 5 or something. You don't have to write 5. This is a phenol and it has a CH3 in ortho position. So you have to write. You have to write. This is one position. This is the second position. 2-methyl phenol. This is also known as orthocresol. Orthocresol. What is cresol? Cresol is nothing but phenol with a CH3 group. Now remember this also, okay? Phenol with a CH3 group. Now the sixth one here, you have how many carbons in the parent chain? 1, 2, 3, 4. 4 carbons. That means it would be, okay, this is ethoxy. What is OH? It is hydroxy. So you have hydrogen and oxygen. That is why hydroxy. Now you have what? You have ethane and oxygen. That is why ethoxy. Okay. Now the sixth one here. Sixth one. Sixth one is what? Sixth one is 1, 2, 3, 4. That means it will be butane. Now there is butane and there is this in this position. That is the first position we have. The first or second position. This is the second position. This is the third position. We have 3, or I can write 2-methyl butane. No. This will be in the alphabetical order. So hydroxy comes first. That is by 2, and this will be 3. 3-methyl butane 2-ol. Butane 2-ol. Okay. Now, what if you have something like this? What if you have something like this, which is unsymmetrical? Which is unsymmetrical. For example, you have wait a second. Let me give you an example of ether. Give you an example of ether. For example, you have like this CH3 O CH CH3 CH3. How will you name this? You have to see which one has lesser carbon. You have oxygen, you have alkene this side, you have also alkyl group this side. You have to see which one has lesser. The one which has lesser will be named first. So this will be methoxy. Methoxy, and you have 1, 2, 3 methoxy. And in the second one, you have this particular methoxy, right? So this will be 2 methoxy propane. Let me give you something another. Oh, here. See, you have alkyl group here also. Now, what you have alkyl group here? You have ethane, and here you have what? This 1, 2, 3. This is propane. Which is larger? Propane is larger, so propane will be the parent chain. Propane. Propane is the larger one. Propane. Then you have what? In the first position, you have this ethoxy group. So you don't have to write 1, you just will write ethoxy propane. If you have the same ethoxy group and you have like this, you have like this. Now this is how much? This is 1, 2, 3. This is again propane. And this ethoxy group, ethane and oxygen, this is ethoxy group. It is in which carbon? It is in the second carbon. So you will be writing like this, 2 ethoxy propane. Now another example is you have same the ethoxy group in this parent carbon 1. This is carbon 1, 2, 3, 4, 5. This is how much? Pentane. So you will write pentane. This is the parent chain. Then you have what? You have ethoxy group. You have ethoxy group in the second position. So you will write 2 ethoxy pentane. Okay. Any problem with the naming? Yes, no, no, fine. Now there are some other hydrocarbons that you have to remember. Some other phenols that you have to remember. That is, you have to remember this CH3 OH. This will be cresol, and particularly this is O cresol. You will write what will be M cresol. You will write what will be P cresol. Okay. Now then you will have, if you have something like this, which is OH here also and OH here also, that means it has hydroxy group in the first and the second position. Then you will write this as catechol. This is catechol, and this is what? This is benzene 1,2 diol. If you have the OH in the meta position, this is OH in the meta position, then this is known as resorcinol. And here the benzene is there, and you have 1,3 diols. 1,3 diol. Now next one is in the para position. The OH is in the para position. 2H is in the para position. This is known as hydroquinone, or this is known as hydroquinone. Hydroquinone, or it is also known as quinol. Hydroquinone, or it is known as quinol. This is benzene 1, 4 diol. The first position 1, 2, 3, and the fourth position you have the OH group in the first, second, in the first and the fourth position. That is why this is benzene 1,4-diol. Now, if you have in ortho position, it is known as catechol. If it is in the meta position, it is known as resorcinol. If it is in the para position, it is known as hydroquinone. You will make this M-cresol and P-cresol also. Note this down. Let me know when you are done. What about Jubena? Okay, fine. I hope you have made the M-cresol like this. And you have made the P-cresol like this. Yes, Fatima, and yes, Jubena. And okay, fine. If you have put the CS3 here and the OH here, it doesn't matter because the distance between OH and CS3 here, the OH is in 1, 2, 3. Same thing, 1, 2, 3 would be written there, and here it is 1, 2, 3, 4. These two is in para, these two are in meta position. It doesn't matter if you have written CS3 here or OH here. I think you have got these right. An important topic now, that is the preparation of alcohols. Preparation of alcohol. Here. Now the first preparation is from. Okay, let us write here the first preparation from the previous chapter from haloalkene. Haloalkene. Okay. Now you will tell me, I'm writing here Rx, and you have to tell me the reagent. What is the reagent? That would give us ROH. You have to name the reagent. Okay. Now, Fatima can be in two different kind of solvents. If you can remember, what is the solvent that you will use here? It can be either, it can be in water or it can be in alcohol. If you have no idea, please say no, sir, I don't know. Just keep waiting for the answers. Again, my goodness. What can I do? If you have Rx, this is Rx. Okay, fine, Juban, I will repeat it. Fatima, is this Rx? Can you please yes sir, no sir, fastly? Okay. This is alcoholic KOH. Does it give alcohol? Then where were you present when I was teaching this? I mean, it is of today's class. Right? what you have to use? You have to use aqueous KOH. Aqueous means water. I guess you know that. I mean, you know what? I have repeated this aqueous thing many times. Now this will give me alcohol. This will give me alcohol plus it will give me KX. Okay. Now this is the reaction. You are very familiar. You know that this reaction can happen either in SN1 or SN2. Okay. You have to just keep that in mind because this is one of the example of nucleophilic substitution. Nucleophilic substitution. The second is from alkene. From alkene. I'm writing a general sequence of reaction here. I'm writing a general sequence of reaction. You have carbon with a double bond carbon, and you have this kind of alkene. What you have to do, you have to do hydration of alkene. Hydration, dehydration means removal of water. Hydration means addition of water. Dehydration, if I say dehydration, then people, you all know it, right? That it is the water has been lost. So this is H2O. And this particular reaction that I'm going to write is kind of reversible. It is kind of reversible. And it will give me the OH will be broken like this. If you want to remember, you have H here and OH here. And this will form a bond like this, and it will give me carbon, a hydrogen here, then the carbon and the OH here, and I will have these two groups, these all groups intact. Okay, so this is alcohol. You have to remember, and this is acidic condition, acidic hydration of alkene gives alcohol via Marconikov's addition. Note this slide fastly. Okay, fine. Now I will look at the mechanism of this reaction. That is the mechanism of hydration, acidic hydration of alkene, acidic hydration of alkene. So first of all, what will happen? First of all, okay, before that, I mean, I have to just ask you one thing. Again, I'm just, please say it after thinking about it. This is a alkene, plus you have H2O in the presence of, now this is somewhat in equilibrium, H plus. Now you will tell me which one of the product will be major. And please remember, this is a Marconikov addition. It is Marconikov addition. Tell me A product or B product, which will be more major product. If you don't know the Marconikov rule, please see your notebook and tell. Correct, Jubana. Fatma, can you, I mean, you don't put your mic on, otherwise I have. Jubana, can you read out the Marconikov's rule from your notebook. Can you read out, Jubana?
The Marconikov rule where a hydrogen at the carbon with more hydrogen atoms.
Hydrogen adds at the carbon with
More hydrogen.
atom, right? So now tell me, Fatima, I have CH3, I have CH, double bond CH2, and I have H plus here, and I have OH negative here. Okay. Now see, H will add on to the carbon which has more number of hydrogens. So H will add on the terminal carbon. Now where will be the OH going? OH will be going in the, this is the major product. Got it, Fatima? And if you're remembering what okay, fine, you got it. Now let us move on to the mechanism. Okay. Jubana, can I have you, please?
Sir.
Don't worry, I will going to ask just the electrophilic sites and the nucleophilic site. You have H2O, the oxygen has lone pair, correct? Plus H plus. Okay, now you tell me what what will be the reaction here? Which electron will be attacking where? Which is in these two, which has the electron rich source, which is the electron source, and which is the electron sink? Tell me electron source and electron sink.
H plus is electron deficient.
Okay.
And
in H2O, which atom is electron rich?
Electron rich.
So it will be forming H3O plus. Correct? Right. This will be forming H3O plus. So the next step would be, okay, now the next step would be, I have alkene. I have this alkene, okay, plus I have H, O, H, and H, and this is positively charged. Now you tell me, now you see here, this oxygen is here with a positive charge. Let me write the positive charge here. Okay, but you have to tell me how many electrons does the oxygen have? Can you count the number of oxygen? The number of bonds is equal to 3. Lone pair is equal to
2.
That means for 3 it has 6 electrons, from 2 it has 8 electrons, correct?
Yes, sir.
So now this positive charge is the formal positive charge, which doesn't have any meaning in sense of electron deficiency. Now, since oxygen has how many electrons? It has 8 electrons, right? So it is not electron deficient. Can you see that?
So I didn't get that concept.
You didn't get that concept. Okay, fine. How many electrons should be in there in the valence shell?
8.
So is 8 there?
It's filled.
That means it is not requiring any kind of electron. It is not electron deficient. Okay, think of it like this. You have a rich person. Okay. Now this rich person has electrons. It has many electrons. It has 10 to the power of 24 electrons. Now it gave how many? Now it has 10 to the power of 24 electrons, and it has 10 to the power of 24 protons also. Now what does it do? It shares one of the electrons. Okay, it shares one of the electrons. So what happens now? If it is sharing, that means it has now 10 to the power of 23 electrons, correct? And 10 to the power of 24 electrons, because it is sharing one of the electrons. Now this rich person will gain a positive charge, correct? Because the protons are more. The protons are more and the electrons are less around it because it has shared one of them. It has not donated one of them, it has shared one of them. That means this will have a positive charge. But if you give this person some electron, he will be offended. He would say, I have already to 10 to the power 24, I have enough of electrons. Since oxygen has enough of electron, that is the valence shell is completely filled. Here, this positive charge is just a formal charge. It doesn't mean it is electron deficient. Now you have to remember there are how many this type of questions will be there in, for example, in second period, if atom has 8 electrons, it is not electron deficient. Okay, for example, if I have NH4 positive, this NH4 positive, you can see here there are how many bonds? There are 4 bonds. And there are how many? That means 8 electrons. That means this is also not electron deficient. So what will be electron deficient site here? The electron deficient site will be the hydrogen which is attached to the oxygen. The hydrogens which are attached to the oxygen. Why? Because oxygen is an electronegative element, hence it pulls electron. Now you remember this part very nicely. What you have to remember is oxygen is electronegative. Okay, that means it will pull electrons. Now, if you add a positive charge here, it will pull more number of electrons because it is positive, right? If it will pull more number of electrons. To what? To minimize this positive charge. Hence, all these hydrogens are very electron deficient. And what will happen? This alkene, which is electron source, will attack on this particular hydrogen, and the hydrogen will have to lose the electrons. It will lose these electrons and it will give it to oxygen to remove its positive charge. Now, what is the thing that we are going to form here? What we will be forming here is either this alkene forms a positive charge here and it gets the hydrogen here. I'm writing CH2 and here I'm writing CH3, or it will get this one, a positive charge here and a hydrogen here. Got it? These two things can happen. This is 1 degree carbocation. Sorry, this is not 1 degree. This is 2 degree carbocation. The positively charged carbon is attached to 2 carbons, and this is 2 degree. This is 1 degree. Since this will be major, this will be in minor form. So I have to do the reaction further with this particular compound. And also you will get one more compound. If I give this hydrogen, you will be making H2O. Correct? Now, the next reaction will be between the major carbocation, which is a positive charge here, and CH3 here, plus you will have H2O. If I write H2O in this fashion, it doesn't have any problem. Okay. Now you can see this carbon is positively charged and it has how many? It has 1 hydrogen, it has 3 bonds. That means it is having how many electrons? It is having 6 electrons. Hence it is electron deficient and it will attack here. You will form this type of compound, CH3 and CH3, and you will have O and H here and H here. Now this is again a positive charge. This is again a positive charge because how many hydrogens are there? There are 2 hydrogens and 1 bond to carbon, 3 bonds in oxygen. It will make it a positive charge. Now this will again react with the H2O that we had here. The H2O that we had here, it will come and it will attack on again the hydrogen atom, H2O that we had in that reaction. It will come here and attack on the hydrogen. And this hydrogen has to leave the electrons to the positive charge of oxygen, and I will be making CH3, CH3, OH plus H3O plus. Okay. Now, as you can see here, the H3O plus is this H3O plus will now I can write this H3O plus as what? H2O plus H plus, H2O plus H plus. Now, what happened here? You have consumed one of the H2O in this reaction. You have used one of the H2Os, but But again, what did you do? You have released with the H plus again that you used here. So this H plus here is a catalyst. The acid used acid used in acidic dehydration is a catalyst. So I can also say this is acid catalyzed. This is acid catalyzed dehydration. Sorry, not dehydration, rather this is acid catalyzed hydration. It's acid catalyzed hydration. Okay, you can note this down. Did you note this one? I guess yes. Now you note this down. See, if you want to, you can write each of these steps. What is happening here? It is the first thing that is happening here is formation of a proton. Then it is the protonation of alkene. Then you have attack of H2O. Okay. In the words you have, you can write this thing. Now copy this slide. Done. Okay, fine. The next reaction is hydroboration oxidation. From the C. Okay, not done, Jubena. Fine. Okay, done. The next reaction is from alkenes only, that is hydroboration oxidation. Hydroboration oxidation of hydroboration oxidation of alkene. Hydroboration oxidation of alkene. Now what happens here? Here you have a diborane which reacts with diboranes. Diborane reacts with alkene. Reacts with alkene to give. Now just remember this statement and you will be able to do the mechanism also. Okay, diborane reacts with alkene to give trialkyl trialkyl borane, comma, on further oxidation with hydrogen peroxide, H2O2, hydrogen peroxide in the presence of aqueous sodium, in presence of aqueous NaOH gives alcohol. Okay. Now what does the reaction say? It has one alkene. This react with diborane. What is borane? It is BH3. Now if you twice the BH3, it will be diborane. So the first reaction is the diborane reacts with alkene to give trialkyl borane. So how this happens? If you have BH3, okay. But diborane is written because the borane exists in its diborane form, okay, in diborane form. But you don't have to worry about that. You will react the BH3 only, okay. You will react the BH3 only. What I have written here, it is BH2 and H1 here. Now what happens here is you get this particular alkene attack on this this particular boron, and this hydrogen leaves out. So this reacts. Now again, why this alkene reacts with boron? Because it is BH3. It will be having H and H. Now this boron is of which group? It is in 13th group. It has how many electrons? 6 electrons. So it has one vacant p orbital, and this vacant p orbital, that's why this is electron deficient. Now if this is electron deficient, what happens? Again, what will happen? This particular thing, it will attack on boron. If it will attack on boron, the hydrogen will leave. And hydrogen will go to this carbon. Hydrogen will leave with its own electron, and it will attack on this carbon, and you will form like this BH2. Okay, and there is the hydrogen here. Now again, what will happen? This is BH2. Can I write it like this? This hydrogen. Now again, what will happen? This alkene there, it will again attack on this. This alkene will attack on the boron, and the hydrogen will get here. So I can write B. That is the alkene that is here. Okay, I have written. Okay, sorry, I need one more. Now this is 1, 2, 3. Okay, this is 1, 2, 3. Hydrogen is not attached here. Hydrogen is attached here. I'm sorry. This is the alkene. Okay, this was the alkene here. Now it has attached to this carbon. This is the alkene here. It has be attached here like this. This is the previous one. Now another one. Okay, and this is the bond which has been formed. This is the previous one bond. This is the new bond which has been formed, and I have one more hydrogen here. So next thing that will happen, again this will react with the same alkene like this. Now again this will attack on this particular boron, and hydrogen will get attached on the second position, and I will get something like this boron with 3 of its bond, and each of them has alkyl group. 1 carbon, 2 carbon, 3 carbon. This is 1, 2, 3. Okay, I have to put this in red to maintain the, and let us put 1 here. This is 1 carbon, this is 2 carbon, this is 3 carbon. 1 carbon, 2 carbon, 3 carbon, 1 carbon, 2 carbon, 3 carbons. Okay, now this is trialkyl borane. This is trialkyl borane. So what happens next? See, I'm going to write this as now. This I can write this as, this is equivalent to, let me use boron here like this. Okay, this is again, I need black, not red. Boron here like this, and I have what group? I have attached CH3. CH2 and CH3. I have to write a CH2 here. Sorry, CH3. This is CH2, CH2, CH3. Okay. Now I will add what? I will add H2O2. I will add 3H2O2 in the presence of NaOH. Presence of aqueous NaOH. Now, if I write H2O2, how can I write this H2O2? I can write this H2O2 as HO bonded to HOH. HO and one OH like this, another OH like this. Now, this will break apart like this. The OHs will attack here and the OHs will attach here. How many of them I have? I have 3 of them. So I will get BOH twice plus how many alkyl groups? I have 3 alkyl groups. That means 3 of OH. That is CH3, CH2, and CH2OH. I will get 3 primary alkene. This is 1 degree alcohol. Now again, what happens in this reaction? First of all, we have an alkene. We have diborane in which the hydrogen, in which the boron has been attacked by the alkene because it is electron deficient and the hydrogen has left. Now this hydrogen leaves and it attaches on the middle carbon. Okay, the more substituted carbon, which has the less number of hydrogen. Okay, the less number of hydrogen. Then next thing that happens here is we have an H replaced by alkyl group. Now the next thing that happened here is again the same type of attack on boron. Then we have 2 alkyl groups. Then we have 3 alkyl groups, and this is called trialkyl borane. The next thing that happens is we oxidize this trialkyl borane with H2O2 in the presence of aqueous NaOH. Now, 3 of the H2O2 molecules that breaks apart in OH negative and OH negative. Okay, OH and OH. So what happens next? Next thing, 3 of the OHs attached to boron to give BOH whole thrice. 3 of the OH attached to the different particular alkane which has alkyl groups which was attached to boron to give a 1 degree alcohol. Okay, you can note this down. If you have any doubt, please let me know. Done. Done, Fatima. Jabana, done. Okay. Fine. Let us do some questions on the same. Start doing these questions, okay? What else can I give you? Following reactions. How many products will be formed in the following reactions? Except, you have to ignore, that means except the byproducts, okay? That means include only organic products. Also draw structure. Okay. Now to make it easy, first you have to tell me what kind of product that will be forming here. It will be alkyl halide, it will be alkene, it will be alcohol. What kind of thing it will be there? Okay, what will be the functional group and where will it attach? I'm numbering the carbon atom now. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4. 1, 2, 3, and 4. Have you understood the question, Fatima and Jubana? Have you understood the question? Yes, from Jubana. Okay, what about Fatima? Did you understand the question? Okay, fine. do this, do these 4 questions. Let me know. Include done. Done. Yes, no, anything, please. Fine. You have 2-3 minutes more. Done? Yes or no? Please say something. Done? Okay. Just match up the answers now. Okay. The number of products. Okay, fine. Functional group, tell me at least. What is the functional group that will be attached in the first question? Okay, right, Jubana. What about Fatima? Which functional group? Okay, Fatima has not answered. So I'm writing here OH group is there. Okay. Now OH group can attach on the second position and the and comma third position. Both of the position OH can group can attach here. So the number of products will be 2. Okay. Now which one will be the major product? The major product will be of the second carbon. Why? Because this has more substituted. This has less number of hydrogen. This will be having more number of hydrogen here. Correct. This has 0 hydrogen. This has 1 hydrogen. Okay. So the major product will be 2 all. Okay. That means in the second position you will be having OH. In the second, now here again there will be OH, and in the second and third position you will be having OH group attached. So there will be 2 products. And then in the second position, this will be again the second position, second carbon. Okay. What about this one? This has only 1 product, which has OH in the third carbon, which is terminal 1. Okay. Now here you will be having, it may seem like you have OH, right? OH will be here also. You have 2, 3, both of them. But if you write it like this, now you have OH here, and in this you have OH here. So the name of this one will be butane 2 all. This is also butane 2 all. So no matter if it same product, so the number of products here will be only 1 product, and here no major or no minor thing, because there will be only 1 product. Okay. Any doubts still here? Then let me know. No doubts. Okay, fine. And I'm ending this class now. You have to note it down.